how to solve inequality problems. Okay, what is inequality problems? Yesterday we solved equality problems.
Yeah.
What is equality problem? When we have x plus y plus z equal to, we said.
Something, yeah.
Right? Now in this case, if they are not equal to, that means if they are less than or greater than, okay, that's when we use inequality problems. Okay, and that is the basis for what is called as linear programming or optimization problem. Okay, optimization problem is about optimizing the resource that you have. Sometimes we might want to increase it, sometimes we want to reduce it. Okay, if we talk about profit, for example, if it is about the profit, you would want to increase the profit as much as is possible. Of course, there's some limitation, but you can increase, you can try to focus on increasing the profit. So we call it as maximization problem. Okay, and let's say you have cost. Cost, you will try to reduce. Let's talk about an example here. Okay, so let's say you own a factory. You own a factory. Okay, and you make two kinds of product. Say, since we are all from IT, right? We can't think beyond IT. So let's say desktop and laptops. You make two kinds of products, desktop and laptops, right? And let's say each desktop gives you, say, 1,000 rupees profit. Okay, and each laptop gives you 2,000 rupees profit. Okay, so every they have factory, right? And they make this. So how much profit can they make? You tell me. How much profit can they make? Give some answer. You're from business background.
So how much would they make the desktop and the laptop for?
So this is the profit.
How much do they make the desktop and the laptop for?
I didn't get a question. How many? What?
How much? Like, what is the cost to make one desktop
This is
and
the
one
profit I'm
laptop?
saying. What does it matter? If the cost is 500, you are making 1,500. If cost is 50,000, you are making 51,000. See, end of the day, you need to know the profit, isn't it?
So then you will make 3,000 for one desktop and one laptop.
And selling price is 51,000. So they are making 1,000.
1,000, yeah.
Yeah. So what is the profit that they can make, maximum profit?
3,000.
3,000. How?
Because
So when you
if
run
they
a
sell one of
business,
each, they will
when
make
you run a
3,000.
business, when you run a business, will you sell only one item?
No.
So we want to make, you can make maximum profit, right? Almost infinity profit, isn't it?
Yes, sir, obviously.
Right? You can make infinity profit.
Yes, yes.
But what is stopping you from making the infinity profit?
Our sources available to produce the products.
So, yes. So there are some constraints that you have to also live with.
Yes.
Right? There are some constraints. We cannot, produce as many as we want. right? One constraint could be the say labor, manpower.
Yeah.
Okay. So let's say if desktop takes 50 minutes to produce, okay, and laptop takes 120 minutes. Okay, we'll keep the same unit to produce. Okay, and you have total of 5,000 time minute available, right? So 50 minutes to make one desktop, 120 minutes to make one laptop, and you have labor, right? You cannot have unlimited minutes. Okay, so you have total of 5,000 minutes. Okay, so here, okay, you can use less than 5,000 minutes or equal to 5,000 minutes. You cannot use more than 5,000 minutes. Yes or no?
Yes, sir. Available time is that only. So it should be less than that.
Then you have component devices. Okay, so let's say there is a motherboard. Okay, and just to it will not be the case, but just to show you how the the constraint would be. So let's say desktop uses only one motherboard. Okay, and laptop uses two motherboard, and you have total of 1,000 motherboard, right? So either you make one desktop or you make how many laptops? How many laptops can I make?
Laptop needs two motherboards. No, sir.
How many laptops can I make? I'm asking you the question.
As many as possible, but within this.
Are 1,000 motherboard is there, each needs two, so you can make maximum 500 motherboard. No, what are you
Yeah.
saying? You guys are not thinking. It is not my class, it is your class also, no?
Okay, sir.
Only I have to think.
No.
Okay, so we have 1,000 motherboard, and each laptop takes two. So maximum laptop
500.
you can make. Okay, so let's look here. What is the minimum laptop and desktop can you make?
Minimum from this 1,000, sir.
Huh?
By 300.
Minimum is 0.
Okay.
You cannot make -1, -2 laptop master. Minimum is 0. You decide not to make anything. You keep everything.
Okay.
Right? Minimum you can make is 0 laptop and 0 desktop. Minimum you can, you decide that I'm not going to make any, when you start the business, right? I'm not going to make anything. So minimum is 0 laptop, 0 desktop. That's the, again, the question is, how much will be your profit, right?
Yeah.
That's what I asked you, right?
Yes, sir.
So to know how much is your profit, you need to know how many laptop and how many desktop you can make, right? So
Yeah.
profit is what? Your profit is 1,000 into desktop plus 2,000 into laptops, isn't it?
Yes.
This is your profit. This is the maximum profit you can make. What is the maximum D and what is maximum L that you can make? That's where the question comes, isn't it? If you know the D and L value, we can easily substitute. We can easily find the profit. But we don't know D and L, right? You want to make 10,000, 1 lakh, 1 crore, right? So first, you will have constraint. First constraint is manpower. Okay, so manpower that you have is 5,000 minutes. That means if you focus only on laptop, how many laptops can I make? If I focus only on laptop, if I focus only on
2000
laptop,
into L equals to
no.
5000.
5,000 by 120. That is profit, 220 profit. So
Okay.
laptop takes 120 minutes and you have 5,000 minutes in your hand. 5,000 by 120 is the number of laptops.
Yeah, into the profit.
Profit am I talking about now? How do you know profit? You have to find L and D.
No, if you are only making laptops, no sir.
First let's see, you still have desktop, right? You have other constraint.
Okay.
You cannot arrive at profit just like that. It's
Yes,
not that
yes.
easy.
Yeah.
Otherwise, everybody will start business, isn't it?
Yeah.
If you know a laptop making 2,000 rupees, everybody will get into laptop business. So you have
Yes.
5,000 minutes and each of them takes 120 minutes. 41.6. Can you make 0.666 laptop? No.
No.
Maximum laptop you can make is
41.
41. Okay. Here maximum is 41. And desktop maximum you can make is only if you make desktop. Right? So it will be 5,000 by 50, which is
100. 500.
right 100.
Yeah.
So you'll make 100.
Desktops.
Okay, maximum you can make 100. Okay, based on first condition. Second condition, we are saying one motherboard and two motherboard for laptop. That means you can make only desktop 1,000. Okay, only laptop 500. Okay, so see, even though here you can see you can make 41, right? And here you are talking about 100. Okay, but here, you know, 1,500. Between these two, this is lowest, right? So somewhere around that you'll be able to make. Let's say, let's put one more condition. Okay, the condition is hard disk. Let's say hard disk you have 1,000. Okay, and let's say both takes one hard disk. Okay, one hard disk for lab desktop, one hard disk for laptop. Let's say. Okay, that means you can make maximum of 1,000 desktop and 1,000 laptops, right? So now let's
Yes.
look at this graph. So I'm going to say that, let's say on x-axis I'll put laptop, on y-axis I'll put number of desktop. So last condition is says you can make, let's say this is 50, 100, okay, or let's say let's do 100, 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. Here you have 100, 200, 300, 400, 500, 600, 700, 800, 900, and say 1,000. Okay. So what we are saying, based on third condition, we are saying you can decide to make zero desktops or 1,000 laptops, or you can decide to make 1,000 desktops and 0 laptops. Okay, so your value will be somewhere in between actual value, right? So this is based on minimum and maximum, right? So you will be making something. So this is the possible. These are the, if you just have one condition, you can decide to make somewhere in between this. Okay, this is your possible solution. Okay, we are not going beyond 0 because you cannot make minus laptop minus desktop. So this is not possible. Okay, based on that, you can make any number of laptop desktop between these values. You can decide to make 0 0 or maybe 100 100 or 500 500 200 300 800 900, you know, anything which is within this. You can't make more than this. Agreed, everyone?
Yes, sir.
Okay, so this is the third condition. Second condition we are saying, okay, 1000 desktop and 500 laptops. 1000 desktops and 500. 1, 2, 3, 4, 5. This is your laptop. So second condition is this. That means if 1000 desktops fine, but second you can't make. If you bring in second condition also, you can't make more than 500 laptops. So now what happened? This area has also eliminated, not possible. These are the constraints. Everybody has to work under constraint. You might have 24 hours to study, but as you know, your power comes only 3 hours a day. So you're constrained by the power. No, you cannot say that I can study more than 24 hours. You can study only 21 hours. Okay, internet is down for next 3 hours. You cannot say 21. You have to say that I can only study for 18 hours. Right? So there are a lot of constraints in our life. So the value that you want to achieve, or that you want to gain, depends upon the constraints that you have to face. So if you now bring in both the constraints, okay, this is our possible solution. We have one more constraint to look at. This constraint says, okay, I can make laptop only 41 and desktop only 100. So desktop is only 100 here and 41. So based on the manpower, only this is possibility. Even though you have other things to make, this is the manpower. Now, let's say demand in the market is only for 50 and your product, okay? The product for which you are supplying, there is only demand for 30 and 30. There is demand only for 30 and 30 products. Though you can make 50, you know, maybe 141, this is not constrained by this. So only this is your solution, possible solution. You get it what I'm saying? Possible solution. Okay. Now, if this is your possible solution, how much is the maximum profit? So you calculate profit at these points. So here, of course, profit will be 0, right? 0, you're not producing anything. So you'll calculate the profit here and calculate the profit here. So everything is a solution. Everything is a solution. Okay, you can make any value between this, because more than this, there is no point, because there is no buyer, you don't have manpower, you don't have resources, you can't make more. This is the constraint. But you can make less than that, of course. But if you want to get maximum profit, you have to make these numbers. Okay, so you have to calculate profit here. Let's say if profit here is, you know, 100K, 1 lakh, and profit here is 110K, 1.1 lakh. Then clearly this is giving you maximum profit. So you'll say, I will decide to go with this value. Okay, this is called optimized problems. Now this is also part of your definite or deterministic solution. After doing all this, you can find a perfect X value. Unlike machine learning, where you don't know what will be the value. Okay, so this is how you solve objective functions. Okay, optimization problems. So what is that we're trying to solve? This is called objective function, where, okay, this is called objective function. What is your objective? In this problem, what is your objective?
Maximize profit.
Maximum profit. So this is how you get the profit, 1000 into D plus 2000 into L. Okay, this is the profit. So this is the formula. To maximize it, I need to know the maximum value of L, maximum value of D, which meets multiple conditions. If there are no conditions, okay, everybody will start doing that. Okay, you'll see that they will manufacture crores of laptops every year, but that's not, demand is not there. They don't have that much of manpower. All those things are cost specific thing. So they need to figure out based on their given conditions. See, sometimes demand is high. People want 10,000 products of yours, but you don't have manpower to make 10,000 products. So you'll have to take the minimum of all those things, isn't it? To get the maximum of the profit, and look at the minimum for all these values, because that is what you can manufacture, minimum of the values. Okay, and there's a reverse here. Cost we don't want, okay, but cost will come. So even if you don't want, again it will come to you. So when it comes to cost, we try to minimize the cost. Okay, so business job is to maximize profit and minimize cost. Yes.
Yes, sir.
Okay. So now, how do we solve it using our SciPy? We'll solve it using SciPy. Let me come up with a problem from internet. We'll try to solve it. Okay. So you have problem maximize your profit. Okay, minimize cost, maximize capacity. Okay, largest rectangle, largest cone that can fit into given paper. I give you A4 paper and tell you draw the maximum possible cone. Answer is maximum possible. What is the maximum size of cone that you can make? No limit. But I'm giving you A4 sheet of paper, so there's a limit, right? You can make a small cone, but I want to make a largest possible cone, right? That is called maximization problem. Okay, so let's look at maximize example here. What it has. Okay, you want to sell a certain number of n items in order to maximize your profit. Market research tells you that if you set the price as $150, you'll be able to sell 5,000 items. And for every 10 cents you lower the price below 150, you will be able to sell another 1,000 items. Okay, suppose that your fixed cost is 2,000 as per the cost of production. Okay, marginal cost is 0.5. Okay, everybody take out pen and paper, or Excel would be better, and solve this paper. So here we have only one variable. How many items you want to sell? Only one variable. So you can solve using pen and paper. Okay, so what? So see the cost. So let me open my Excel. Okay. So let's say that you want to make number of items. Okay, number of items you want to make is, let's say, 1. So what it says is, okay, maximum profit that you can get for each price is $150, right? So you want to sell 1 million, right? 10 million, 100 million, 1 billion, right? You can sell, but there are constraint. Constraint is that market research tells you that if you set the price as 150, you will be able to sell 5,000 items. For every 10 cents you lower the price below 50, you will be able to sell another 1,000 items. Okay, so if I set my price, okay, okay, so here you see it is items. Okay, this is your price. Okay, and this is cost, right? And so cost is made up of fixed cost and variable cost. Okay, if you want to set up a factory, right? So the land, okay, whether you use it not, okay, you have to pay the rent for the land, okay, machineries, okay. Variable cost is number of people, which changes, right? Number of people, okay, or say electricity cost. Electricity is a great example of variable cost. If you don't want to do it, just shut it off. You will not pay any bill. If you are using 24 hours, your bill will also increase, isn't it? So you have fixed cost and you have variable cost. Okay. So what it says is, if you are able to, if you put this as $150, okay, price is 150. So what is the total cost? Total selling price. Okay. First we'll find the total selling price. Total price. Okay. If you have 5,000. So total price will be 5,000 into 150. Okay. Now this is your cost. Fixed cost. What does it tell about fixed cost? Okay. If you're able to sell another, okay, so we'll talk about it later. Suppose your fixed cost is 2,000 and the marginal cost is 0.5. So your fixed cost is 2,000.
Yeah.
Okay. And variable cost is $0.5. Now your total VC, TVC will be your N into 0.5. And total cost TC is going to be this plus your fixed cost. So your total profit is total selling price minus total cost price. So 3,000 is your profit if you sell 5,000. What it says is, if you're able to reduce by 10 cents, you'll be able to sell how much? 1,000 more, right? So now,
Yes, sir.
if my selling price goes to 140, I'll be able to sell 6,000. If my selling price goes to 130, 120, $1, 0.9, I'll be able to sell, I'm going to sell 7,000, 8,000, 9,000, and total price, okay, is nothing but price into quantity, right? So 1.5 into 5, 1.4 into 6, these are your, so
Price, total price.
right here you see 9,000, 10,000. Okay, it is increasing, right? Okay, now you see the total price 7,000, 8,400, 9,000, 9,600, 9,900, 10,000, then starts decreasing now, right? It starts decreasing. You know why? Because see, initially your price is more than the difference that the quantity is giving you more profit than the price decrease. Initially price decrease is less, quantity is more, so it is offsetting. But as you keep on going, 0.8, 0.7, 0.6, 0.5, 0.4, 0. It's like this, right? If you give 10% discount, let's say you get 10,000 people. If I give 50% discount, how many people can I expect? More or less?
More.
So if I give 100% discount, okay. So what happens is, after $1, the change in price is more than the benefit that you're getting because of extra. Okay. So this is one reason. And second, you see, the variable cost is 50 cents. To make one item, you are spending 50 cents. So can you reduce the price below 50 cents? You cannot reduce price below 50 cents because that's a definite loss. Right? If I'm spending, let's say, training institute, for every 1 hour, let's say I have to pay 1,000 rupees to the training institute. And from student, I'm collecting, let's say, 100 rupees per hour. So if I have a student less than 10, I'm making loss or not? Okay. So I have to have minimum 10 students so that I can recover my cost. Yes or no? Recover my
Yes, sir.
cost. So if my variable cost itself is 0.5, that means for every item I'm making 0.5. Then you have fixed cost. Assuming that fixed cost is 0, let's say assume that fixed cost is not there. Still then you can't produce below 0.5. Okay, we'll do and see what happens. Now your total price is also decreasing, right? Now fixed cost will remain 2,000, whatever it is, right? Fixed cost will not change. Okay, variable cost per item also as per the problem, it doesn't change. It doesn't change. Okay, so total variable cost will increase, isn't it? As you produce more and more, it has to increase. 2,500, 3,500, 4,000. Okay, it is increasing. So what is total cost now? 2,000 plus 2, 4. 2 plus 3, 5. Okay, this is the total cost. Now what happens to your profit? So start with 3,000 profit. You'll go down 600, then loss, and then you're making loss, right? So, okay. So now you see at what point are you making maximum profit? You are making maximum profit in this range. Okay. So this is 3636. Okay. That means you can decide to make any product between 7,000 and 8,000 to get maximum profit, which is $3,600. If you make less than that, you'll get less profit. You're still in profit. Okay.
Yeah.
If you do more than that, also you're in profit. But this is the right value where you get the maximum profit. Getting the maximum. Your aim is to get maximum profit, isn't it? So you should not make more than 8,000, and you should not make less than 7,000. Anywhere between 7,000 and 8,000 is the best way to implement.
Yeah.
Okay, so that you get maximum profit. Okay, so for one variable you don't need SciPy, but what if you have two variables? Okay, so let me talk about optimization with two variables. 2, 3. Okay, more and more complex. Okay. Okay, I have to search for it. Okay. If not, anyway, it's late, right? We can do it in next class. Okay? It'll take long process time also. We'll do one thing. We'll meet in next class. Okay. Expression will take time as well. Okay. So see here. Okay, let's form the problem and then we'll solve it later. So here you see it says assembly line. Okay, manufacturing plant involving F full-time workers, P part-time workers, and R robots has a total production level of 80 gizmos per day. Each full-time workers compensation total is 200 per day. Each part-time workers compensation 80 per day, and each robot maintenance cost is 40 per day. The daily operating budget is 4,000. How many each type of worker and how many robots would be employed to maximize total daily production? Okay. So your aim is to maximize their time, but minimize the cost. Okay. So what is the cost here? Okay. So let's assume